Hi everyone, this is Dr. Jenkins. I really apologize for this, but due to the circumstances, it's really all that we can do. So unfortunately, we're in a situation where we have not met for 2 weeks, which makes me very sad actually. Last week was a 2-hour delay, so we missed it because of the 2-hour delay. And I was planning on doing the makeup this week. However, I have had a death in the family, and I am leaving town to attend the services, so I will not be able to be here Thursday for lab. So, in lieu of this week's lab, I am recording a video here. I am going to ask you to do a couple things, but nothing that you can't do on your own, okay? So let's just quickly review these 2 labs. I'm here to give you the bullet points. I'm going to email you this video link, and I'm also going to email you copies of the labs. So if you don't have your lab manual, you can just follow along with your labs, okay? So last week, with the 2-hour delay because of snow, we missed the GI physiology lab. Right here on this screen is what you need to know from that lab. So this is what you're going to want to write down. This is what you're going to want to study for your next lab exam, which isn't for a couple weeks, okay? We were looking at enzymes, okay? And I know Dr. Thompson has talked about this, but let's just make sure. Enzymes are made up of protein. Didn't we say that one function of proteins is that it helps to form chemicals? Well, this is one chemical that it helps to form. The function of enzymes is to speed up chemical reactions. The fancy word for speeding up is catalyzes, but we can just say speed up. What we're going to be talking about enzymes in reference to is chemical digestion. You know, last time we had a lab before the exam, we made the GI tract out of clay, so we learned about the anatomy. But what about the physiology? Well, we may remember, chemical digestion is to break down food using chemicals. What kind of chemicals? Enzymes. And the reason we absolutely need enzymes is because they speed up chemical reactions. Then, please review some of the characteristics. Enzymes are reusable. That's super efficient. So an enzyme can go help speed up a chemical reaction, and then it can go right away to another chemical reaction and help speed that one up. Usually, almost always, enzymes end in the suffix ase. So for example, one enzyme we're going to talk about is amylase. Amylase, protease, lipase, pyruvate kinase, acetylcholinesterase. Anytime you see that ASE, we're pretty certain that it's an enzyme. Lastly, these enzymes demonstrate something called specificity, which just means it's specific. For example, the enzyme amylase can only work on starch. The enzyme protease can only work on protein. The enzyme lipase can only work on fat. So each enzyme can only work with a specific substrate. So please review those things about enzymes. And then we can see the second thing to review from this lab is this chart. If you're looking at the handout that I emailed you, it is on page 27. If you have the lab manual, it might be slightly different, but it's going to be close to page 27. Table 2, Summary of Chemical Digestion. Folks, this is what we would have done in the lab. We started with a starch, for example. Let's remind ourselves that a starch is a complex carbohydrate. To starch, we added the enzyme for starch. What is the enzyme for starch? Amylase. Amylase, when added to starch, will help break it down. It will speed up the chemical digestion. If we start with a huge complex carbohydrate, add the enzyme, it's going to get broken down into its smaller pieces. What do we break down big complex carbs into? Simple carbs. So we start with a big complex carbohydrate, add the enzyme, which will help break it down into its smallest piece, which is a simple carbohydrate. Then we did fat. I'll change colors just for the fun of it. The enzyme that we added to fat is lipase. Lipase, which shouldn't be that surprising because lipids, lipids are fat, so lipase. We're going to break fat down into, it actually is glycerol, but we were looking at the fatty acids. So we start with a big fat, we add the enzyme specific to it, then it gets broken down into its smallest piece, which is fatty acids. Lastly, we have protein. I'll use purple. For protein, the enzyme we added is protease. You should know already, we start with a big protein. It's going to get broken down into amino acids. So all you need to review for this lab, in addition to what we talked about with enzymes, would be the basics of what we did. Fill out that chart on page 27. We started with a big macromolecule, and then we added an enzyme, and it got broken down into its smallest piece. So these are the enzymes I'd like you to know: amylase, lipase, and protease. You should know with what we started with and what it got broken down into. Now, you don't need to know the specific indicators, but all I want you to know about the indicators is the function. So you don't need to know the specific indicators for all three, okay? Just be able to give the function of an indicator. An indicator is something added to see a color change. Something added to see a color change. Something added to see a color change, and that color change tells us if a nutrient is present. Tells us if a nutrient is present. So if you think back to lab number 2, where we tested all those foods, we tested Gatorade, we tested the Cliff Bar, we tested chocolate milk, the egg white. We used indicators. You may recall, if something turned dark blue or black, it was positive for starch. If something turned yellow, it was positive for protein. That's because we added an indicator solution. So the only function of the indicator solution is to help something change colors. I just want to point out it's not the same as the enzyme. The enzyme is what actually speeds up the chemical reaction, right? The indicator is only there so something will change color, and that'll let us know whether or not a certain nutrient is present. All right. Now, the lab that we had planned to do this week is our computer dietary analysis lab. I'm going to email this to you as well. Here are the important things that I would be reviewing in person, but because I cannot be there, we're going to review it right here on this video. As you can see, again, if you have the handout, on page 29, let's review the acceptable macronutrient distribution ranges, AMDR. Usually when I'm in class, I go through a series of questions. I like to ask people, what do you think we need the most of? Carbs, fats, or protein? So I guess I can ask that, even though you can't answer me right now. Think about it. What do you think we should have the most of in our diet? Do you think your daily diet should have the most carbohydrates? Do you think it should have the most protein? Or should it have the most fat? In person, I usually draw this out. You know how I do. But I'm just going to answer you right now, and that's carbohydrates. We need the most carbohydrates because it is our cell's main fuel source. You should know somewhere between 45 to 65% of our daily diet should come from carbohydrates. Now, it's a range because we're all different. An endurance athlete would be on the higher end. A diabetic would be on the lower end. So we have a range to account for individual differences, but by and large, most everyone will fit into this range. So we need the most carbohydrates in our daily diet. You need to know these ranges, okay? What do we need the next most of? Fat. Somewhere between 20 to 35% of our diet should come from fat. And then we have protein on average, maybe somewhere between 15 and 30%. So fat and protein are pretty similar. All right. Before we go on to the next part, just like I would if we were meeting in person, let's talk about protein for a moment. Obviously, protein is really important. So why is it that we don't need as much through diet? Protein is really important. Why do we not need as much of it through our diet? The answer is our bodies can make protein for us. Do you remember the essential and non-essential amino acids? Yes. The non-essential amino acids are the amino acids that our bodies can make for us. Over half of our amino acids our cells can make for us. So I'm not a protein hater, people. I feel like that's the word on the street, but I'm not. I'm not a protein hater. I'm just telling you the physiology of it. Our cells make over half of the protein we need. Therefore, we do not need to get as much of it through diet. Now, our body does not make carbohydrates or fat in the same way. It doesn't. But all of our cells are little protein-producing factories. Okay? And then I usually go on to talk a little bit about what if we bring in more protein than we need? Can we store large amounts of protein? No. We can store large amounts of fat almost endlessly. We can store a lot of glucose as glycogen. So our body has the ability to store a lot of fat. Our body can store a lot of carbohydrates, but we cannot store a lot of protein. So we can't store it in large quantities. How do we get rid of excess protein? We usually get rid of excess protein through sending it to our kidneys, and then we pee out the breakdown products. But you see, protein has that nitrogen, that pesky nitrogen, which makes it difficult to break down and get rid of. So here we see, if we bring in more protein than we need, we can't store large amounts of it. It's hard to break down. We'll try, but it's hard. So what if you bring in more protein than you need, and it's more protein than you can store, and it's more protein than you can easily get rid of? Your body will have no choice but to turn it into fat. So some people, I feel like, think they're doing the right thing. Oh, I need protein. I need protein before. I need protein after exercise. I need protein in the morning. I need protein at lunchtime, at night, all the time. I need a protein supplement. Well, we need protein, yes, but remember that our body makes a lot for us. And if we bring in excess, we can't store large amounts of it. It's hard to get rid of. And your body might end up storing it as fat, which is the exact opposite of what your intention was. Okay. The second part, the actual lab that we would be doing this week is you're going to go to 3 websites. You can follow along. in your lab book. Unfortunately, I believe the free dieting website that's on your list there is no longer, free dieting is no longer allowing us to get calculations, so just ignore that one. I think it's free dieting. Or maybe it's Fit Day. There's one of them that we can't get onto anymore. Maybe it's Fit Day. I think it is Fit Day. So, I think this one is free dieting. I apologize for the error. So, you can just ignore the Fit Day one, but you can go to these three. So, this is what I'm asking you to do. Okay? Your task is to go to these three websites, MyFitnessPal, Free Dieting, and MyPlate.gov. You're going to have to make a profile for, I think, the first one at least. So make sure you write down somewhere the username and password that you use. And the instructions are in the lab. Sometimes the websites change frequently, so the instructions are easily outdated. In most cases, it's going to ask you your age, height, activity level. Age, height, weight, activity level. And it's going to spit out to you a recommended number of calories. When you go to free dieting, you're going to select daily calorie needs on the left-hand side of the screen. For this last one, it's not choosemyplate.gov, it's myplate.gov. And I've listed the order of what you need to click. On the top bar, you'll click Resources. On the drop-down menu from that, click Tools. And then you'll hit My Plate Plan, and you'll click Start. Your job is to fill out the table hold on, I have it right in front of me here. Your job is to fill out the table on page 34. Table 1, page 34. This is going to be a summary of these three websites. You can just forget about Fit Day, but you can get values for MyFitnessPal, Free Dieting, and Choose My Plate or myplate.gov. Okay? So it's going to give us a number based on your age, height, weight, activity level. By going to three or several different websites, we can hopefully get a better, more accurate reading, and it won't have any outliers. Some websites will give you everything that you need. Some will give you total calories and grams of carbs, fat, and protein that are recommended for you. But some websites will only give you total calories. But not to worry, my friends, because we can do the math. So for the websites that only give you total calories, you're going to have to do a little bit of math. And this is listed all in there. Let's say, for example, choosemyplate.gov. I'm going to give you an example. Let's say, what color have I not? I can use blue. Let's say choosemyplate.gov tells me that I need 2,200 calories. And that's it. Guess what? Just with that, I can do the equations to figure out how many grams of carbs, fat, and protein are recommended for me. In order to do this, you're going to have to first pick your own AMDRs. All right? So what you're going to have to do is pick a number within each range that makes sense for you. And those three numbers need to add up to 100. I will use myself as an example. So let's say I'm looking at myself for carbs. I do more cycling, which is more of an endurance. So I might think I need about 60% carbs. Then I would think about fats. Well, as an endurance athlete, am I going to rely on fats for energy? Yes, because I exercise at a lower intensity for a long period of time. So what if I said 25% fats? Well, then what's left for proteins? 70, 85. What's left for protein is 15%. I might look at that and be like, well, 15% is kind of low for protein. So maybe I'll add some to protein and take some away from carbs. Maybe I'll do, what was it, 60? Maybe I'll do 56% carbs and I'll do 19% protein. So you might want to play around with them. There isn't necessarily one right or wrong answer. Just make sure that your values that make sense for you fit into these ranges and that they add up to 100. Now we can do these equations. I have how many calories that website recommended, so I can put that where it asked me to. Oh, that's the wrong one. Hold on. Getting a little carried away here. Down here. And then I'm going to input these percentages. So what was my percent carb? 56. Percent fat for me was 25. And then 19. Divide by 100. Just move the decimal place over to 0.56. 0.25. 0.19. Now your numbers are going to be different because we're different people. But I just want to show you how this works. So for carbohydrates, I would do 0.56 times 2,200. And that gives me 1,232. If I follow the equation over, I just couldn't fit it. It's going to then ask me to divide that by 4. Oh, I had the wrong thing. 1,232 divided by 4. That's 308 grams of carbohydrates for me. And that number makes sense. Then I'll do fat, 25%, 0.25 times 2,200 equals 550. But for fats, we're going to divide by 9 because fat gives us more energy per gram. That's reasonable, 61 grams of fat per day. And then I'll do protein, 0.19 times 2,200 equals 418. And we're going to divide that by 4. And I get 104. That's also reasonable. So some websites, again, some websites will give you everything you need, total calories recommended and percent needed of carbs, fat, and protein. Others will only give you the daily recommended calories and you can do the rest. So what you need to do is go to these 3 websites, MyFitnessPal, Free Dieting, MyPlate.gov. When needed, do the equations on your own, and you need to fill out Table 1 on page 34. Okay, fill out Table 1 on page 34. Now, I am going to introduce a diet analysis assignment, but I'm going to wait until I see you in person to do that. All right, so I'll wait to give you the assignment until next week. Last reminder, next week we are meeting at the Price Chopper across the street. So don't even come to the Science Building next Thursday. What's the date? March, let me see here. Next Thursday, March 9th. Don't even come to the Science Building. We're going to meet at the Price Chopper. When you walk into the Price Chopper, there's some chairs and tables to the left. So walk in the Price Chopper across the street from campus and walk immediately to the left. All right, folks, I will see you then, I promise.